Chapter 2. Understanding the weather. Essential inquiry. Students will identify the major elements of weather, temperature, humidity, precipitation, wind, and atmospheric pressure and explain how they determine the weather of a place. Students will learn about various weather measuring instruments such as thermometer, barometer, rain gauge, hygrometer, and anemometer, and will understand how data from these tools helps in forecasting weather. Students will observe that weather changes frequently and analyze how different weather elements become dominant in different seasons and situations such as cyclones, heat waves, low winds, or monsoon rains. Students will differentiate between weather, short-term atmospheric conditions, and climate long-term patterns, laying the foundation for climate studies in the next chapter. Students will recognize the impact of weather on human life, including daily activities, agricultural practices, safety preparations during extreme conditions, and ecosystem behavior. Introduction to weather and the atmosphere. Weather is an ever-changing condition of the Earth's atmosphere that affects our daily lives. A cold morning, scorching summer heat, or a thunderstorm all influence how we behave, whether we wear warm clothes, use fans, or stay indoors during a storm. Weather is the state of the atmosphere at a particular place and time. It is dynamic and can change within minutes or hours. To understand weather, we must understand the atmosphere, the blanket of air surrounding the Earth. It provides oxygen for humans and carbon dioxide for plants, protects us from the sun's harmful ultraviolet UV rays, helps regulate Earth's temperature, making life possible. The atmosphere is made of different layers. The troposphere, the lowest layer, lies closest to the Earth's surface and extends roughly 6 to 18 kilometers upwards. Elements of weather. Understanding the weather requires us to look at its basic building blocks, often referred to as the elements of weather. These elements are the various physical conditions of the atmosphere that, when taken together, define the state of weather at any given place and time. These include 1. Temperature, 2. Precipitation, 3. Atmospheric pressure, 4. Wind, speed and direction, 5. Humidity. Each of these elements can be observed, measured and analyzed to gain a comprehensive understanding of how the weather behaves. Let us explore each one in detail. 1. Temperature. Temperature refers to how hot or cold the air feels at a particular time and location. We sense temperature directly through our skin and adjust our clothing and activities accordingly. For instance, during summer, we wear cotton clothes and stay in shaded areas, while in winter, we wear woolens and seek warmth. 2. Precipitation. Precipitation is the term used to describe any form of water that falls from the sky to the Earth's surface. This includes rain, snow, hail, sleet, and drizzle. Among these, rainfall is the most common form of precipitation and is essential for life on Earth. It replenishes groundwater, sustains crops, fills rivers and lakes, and helps maintain natural ecosystems. Precipitation is measured using a rain gauge, and its measurement is usually expressed in millimeters mm. 3. Atmospheric pressure. Atmospheric pressure refers to the weight of the air above a given point. While we cannot see it, we can feel its effects. For instance, before a thunderstorm, the air may feel heavy, and you might experience uneasiness or even breathlessness. This sensation is related to a change in atmospheric pressure. Pressure varies from place to place and at different altitudes. It is highest at sea level, where the weight of the air column above is greatest, and lowest at high altitudes, such as on mountains, where the air is thinner and contains less oxygen. Meteorologists use a barometer to measure atmospheric pressure, with the standard unit being the millibar MB. 4. Wind, speed and direction. Wind is the movement of air from areas of high pressure to low pressure. It is one of the most dynamic elements of the weather and can range from gentle breezes to violent storms. Wind is responsible for distributing heat and moisture across different parts of the earth, thereby playing a major role in shaping regional climates. Wind has two main properties. Direction, from which the wind is blowing, for example, northeast, southwest. Speed, how fast the wind is moving, usually measured in kilometers per hour km. High. In airports, windsocks are also used to give pilots a quick visual clue about wind conditions during takeoff and landing. 5. Humidity. Humidity refers to the amount of water vapor present in the air. It is an invisible but vital component of the atmosphere that affects how comfortable or sticky the air feels. High humidity levels can make the weather feel warmer than it actually is, while low humidity can lead to dry skin and respiratory discomfort. A hygrometer is the instrument used to measure humidity. Traditional weather forecasting. Long before the invention of satellites, weather stations, or modern scientific instruments, human beings found ways to understand and predict the changing weather. They did this by carefully observing natural signs and patterns in their surroundings. This practice, known as traditional weather forecasting, has been passed down for generations and continues to be used, especially in rural and agricultural communities. Observing nature, the first forecasters. Some of the traditional indicators include birds flying low to the ground. This is often a sign that air pressure is dropping and rain may be on its way. Ants carrying eggs to higher ground, a common sight before heavy rain. This behavior is nature's way of protecting future generations from flooding. Frogs croaking loudly. This is widely believed to indicate the arrival of rain, especially in tropical regions like the Western Ghats. Pine cones opening and closing. Pine cones react to moisture in the air. When it's dry, they open to release seeds. When it's humid, they close to protect them, offering a natural forecasting of rainfall or humidity levels. Instruments to measure weather. To study and predict weather, scientists use various instruments that measure elements of the atmosphere, such as temperature, rainfall, air pressure, wind, and humidity. These tools allow meteorologists to collect accurate data and understand changes in weather conditions. Measuring temperature thermometers. Temperature tells us how hot or cold the air is at a particular time. It affects daily life, health, crops, and weather forecasting. A thermometer measures temperature and may be of three types: clinical for body temperature, laboratory for substances, or meteorological for outdoor air. The scale is marked in degrees Celsius or degree Fahrenheit. Measuring precipitation rain gauge. Precipitation includes rain, snow, hail, and sleet. Rainfall is essential for water supply and farming. It is measured using a rain gauge, which has a funnel, measuring tube, and scale to record the collected amount of rain. Measuring atmospheric pressure barometer. Atmospheric pressure is the weight of air pressing on Earth. It influences clear or stormy weather. A barometer measures air pressure and may be a mercury barometer, aneroid barometer, or digital barometer. Pressure is recorded in millibars, or hectopascals, with 1013 megabytes being average at sea level. Low pressure, cloudy, stormy weather. High pressure, clear, dry weather. At high altitudes like Ladakh, pressure may drop to 650 megabytes, causing breathing difficulty. Soldiers in places like Khardung La must acclimatize to these low oxygen conditions. Measuring wind vane and anemometer. Wind is the air moving from high to low pressure. It has a direction and speed. A wind vane shows the direction from which the wind blows using a rotating pointer. An anemometer measures speed with spinning cups attached to a shaft and a dial or digital display. Measuring humidity hygrometer. Humidity is the amount of water vapor present in the air. It affects how temperature feels. High humidity feels hotter, while low humidity causes dryness. It is shown as relative humidity. Percent. 0% extremely dry, not natural. 100% fully saturated air, likely rain. 20-40% dry. 60-80% humid. A hygrometer measures humidity. Types include hair hygrometers, psychrometers, wet and dry bulb thermometers, and digital hygrometers used at home. Weather stations and automated systems. Understanding the atmosphere is a continuous task one that involves observing, recording, and analyzing weather data from different locations and over long periods of time. This is where weather stations come into play. These centers are the nerve centers of meteorology. What is a weather station? A weather station is a site equipped with tools and instruments for observing and recording atmospheric conditions. These stations are often found in cities and towns, airports, hill stations, seaports, remote or high-altitude areas, automated weather stations (AWS). In recent years, the need for faster, more accurate, and round-the-clock data has led to the development of automated weather stations (AWS). These are self-operating units equipped with high-tech sensors and data loggers that continuously monitor weather conditions without human intervention. Each AWS typically includes temperature and humidity sensors, wind vane and anemometer, barometric pressure sensor, rain gauge, automated tipping bucket type, data logger and battery, solar panel. AWS units are compact, they don't require large infrastructure. Efficient, they record data every minute or hour. Remote friendly, can be installed in inaccessible or harsh environments. The collected data is transmitted via satellite or internet to meteorological centers. AWS systems are particularly useful in locations that are difficult to access or lack regular manpower, such as mountainous regions, desert areas, glacial valleys, offshore platforms. AWS in Sikkim and weather data mapping. In 2023, the National Disaster Management Authority (NDMA) installed an automatic weather station AWS Lake in Sikkim, situated over 4,800 meters above sea level, to monitor the high risk of glacial lake outburst floods (LOFs). This AWS measures rainfall, temperature, wind speed, and air pressure, and sends early warning signals to protect downstream communities from sudden flooding. Weather data collected from AWS and other stations is processed using computers and weather software, mapped onto charts, compared with historical records, and used in forecasting models. This information helps meteorologists develop weather maps, cyclone tracks, rainfall charts, and temperature heat maps. These maps use symbols and color codes to indicate conditions such as thunderstorms, heavy rain, heat waves, cold spells, fog, or dust storms. Such weather maps guide government agencies in disaster planning, provide public alerts through media, and help farmers and fishermen make informed livelihood decisions. Weather warning systems and maps. The IMD uses a color-coded system to communicate levels of warning. Green, no warning, safe conditions. Yellow, watch, be updated and alert. Orange, alert, be prepared for likely impact. Red, warning, take immediate action. This color scheme helps both official agencies and the public understand the seriousness of the weather conditions. Consider a weather map showing India on 19 May 2024. It displays various icons like lightning bolts for thunderstorms, snowflakes for heavy snow, wavy lines for wind alerts, thermometers for heat waves. Different regions of the country are shaded based on the weather they are expected to experience. Such maps are essential for regional planning, school and office announcements, closures, event scheduling. Concepts introduced. Weather. Weather refers to the condition of the Earth's atmosphere at a particular place and time. It includes daily changes such as temperature, rainfall, wind, humidity, and atmospheric pressure that we experience around us. Troposphere. The troposphere is the lowest layer of the Earth's atmosphere where all weather phenomena occur. It is also the layer in which humans, plants, and animals live and breathe. Atmospheric pressure. Atmospheric pressure is the force exerted by the weight of air on the Earth's surface. Changes in atmospheric pressure help meteorologists identify low-pressure systems such as storms and cyclones. Relative humidity. Relative humidity is the measure of the amount of water vapor present in the air compared to the maximum amount it can hold. High humidity makes the air feel sticky and slows down evaporation, while low humidity causes faster drying. Automated Weather Station, AWS. An automated weather station is a self-operating system that records weather data such as temperature, rainfall, wind, humidity, and air pressure using sensors. It provides accurate and timely information for weather forecasting, disaster management, and agriculture without human intervention.